Here we're going to talk about rational and irrational numbers. A rational number r is a number which can be written in the form r equals a over b, where a and b are integers, whole numbers, b is non-zero. B non-zero is very important because we're not allowed to divide by 0 because it's not defined. Examples are 7 over 11, 57 over 13, minus 9 over 5. They're all rational numbers. When we divide a by b, we could end up with an integer. Any integer is always rational, as n equals a over b, where n equals a and b equals 1. In general, a equals bn. Example, 7 is equal to 7 over 1. So it's automatically rational. The denominator is 1. In general, rational numbers are fractions, i.e. proper or improper. If a number cannot be written in the form a over b, with a and b integers, b non-zero, then we say the number is irrational. So a number will either be rational or irrational. Famous examples of irrational numbers are pi, e, and root 2. We can only approximate these numbers to any degree of accuracy we wish. To 2 decimal places, pi equals 3.14, e equals 2.72, root 2 equals 1.41. You can quickly verify this on your calculator. Irrational numbers have an infinite decimalization, i.e. it never terminates. I.e. all the numbers after the decimal point go on forever and ever and ever. They never stop. If it terminated, then it would be rational. Example, suppose pi terminated at 2 decimal places, i.e. pi equals 3.14. Then we can write this as 314 divided by 100, and therefore it would be rational because it's in the form a over b. A is equal to 314, b is equal to 100, and they're both integers. So that satisfies the definition of rationality, therefore it would be rational. To prove a number is irrational can be very difficult, and it depends on the number. Irrational numbers actually contain different subclasses of numbers, which we won't study in this video, such as transcendental numbers, algebraic numbers. All I will say, and you'll have to trust me on this, is that pi and e are transcendental numbers and root 2 is an algebraic number. It's harder to prove a transcendental number is irrational than an algebraic number. An algebraic number is a number which is a root of a non-zero one-variable polynomial with rational coefficients. Example, x squared minus 2 equals 0, i.e. x squared equals 2, so x is plus or minus root 2. So root 2 here is an algebraic number because it's a root of a polynomial in one variable, and it's non-zero. If an irrational number is not an algebraic number, then it's transcendental. Note, all rational numbers are algebraic, but the converse is false. Root 2 is algebraic, but it's irrational. Root 2 cannot be written in the form a over b, where a and b are integers. And we will prove that in another video. To prove pi or e is transcendental is very technical and would require a video on their own. So that concludes the video. Have fun with rationals and irrationals. Thanks for watching. Please subscribe, and I hope to see you on the next video.